Welcome to CS 1401 video 9.2, in which I'll look at the iteration construct for. In the last video, I talked about iterating with while loops. In this video, I'll talk about iterating with for loops. When the condition in a loop involves a range of values, especially a range of integer values, there's a more compact way than while to express the loop, and that's with the for construct. In the countdown algorithm we looked at in the last video, the variable controlling the condition was decremented explicitly within the body of the loop. That is, the last statement of the loop was the number is the number minus 1. We can move this decrementing activity into the specification of the loop condition itself using the for construct. In general, the form of a for loop is as follows. There's the keyword for, followed by 3 arguments. There's an initialization, which sets the first or initial value of a variable that we're going to be using to check whether to see to continue doing the loop. There's the loop condition, which looks at that variable and determines whether or not to keep executing the loop. And the third argument is an increment. It changes the value of the variable so that we expect at some point the logical value of the loop condition will be false and we'll stop executing the loop. The body of the for loop will be a set of statements, things to do. Let's try changing the countdown algorithm that we implemented with while to an algorithm implemented using for. So I'll call my new algorithm countdown again. It'll still take a single argument called the number, but now I'll use a for loop. The loop reads for, and the initialization is we'll set some variable I to be the number. And in general, computer scientists represent integers with variables that have the names I, j, k, and so forth through roughly n. The loop condition will be that I is greater than 0, and our increment will in fact be a decrement. Every time we execute the loop, we'll decrease the value of I by 1. The body of the loop will be to print the number. So what will happen? Initially, I will be the number, for instance 6. 6 is greater than 0, so we'll execute the body of the loop and print the number. And once we've executed the body of the loop, we'll decrement I by 1. We'll check to see if I is greater than 0. If it still is, we'll execute the body of the loop again, decrement the number, and so forth until I is no longer greater than 0, at which point the loop terminates and will print done. In the countdown algorithm, I counted down the numbers from the number down to 1, decrementing the loop variable I each time we executed the loop body. It's also possible to count up from 1 to the number, in which case we'll increment the loop variable I each time we execute the loop. So here's my algorithm count up. Again, it takes a number as the sole argument. And this time we'll initialize the loop with I being equal to 1 because we're going to start printing out our numbers starting with 1 and working our way up to the number. We'll check to make sure that I is still less than or equal to the number. And each time we execute the loop, we'll increment I by 1. So the first time we check to see if the loop should execute, if I, which is going to start out as 1, is less than or equal to the number, and so as long as the number is 1 or greater, it'll execute. So if all that's true, I'll print the number, which is the body of the loop, and then after executing the body of the loop, I'll increment I by 1. Next, we'll check to see if I is still less than or equal to the number. If that's true, I'll print the number again, executing the body of the loop, and increment I by 1. And so forth until eventually I is no longer less than or equal to the number, in which case the loop will terminate and I'll print done. Here's my implementation of these two algorithms, starting with count down again. The class will be count down again. It will take an argument from the command line, an integer called the number, and instead of using a while loop, I'll use a for loop. So I'll initialize the loop variable I to be an integer equal to the number. My loop condition will be that I is greater than 0, and each time the loop executes, I will decrement I by 1. The body of the loop is simply to print out I. And you'll notice I don't have curly braces around the statements in the body of the loop. That's because there's only one statement in the body and I don't need curly braces. Well, at some point, I will no longer be greater than 0 because I'll keep decrementing it until it reaches 0. At that point, the for loop will terminate and I'll print out done. I'll compile countdown again and execute it with the value 5. And sure enough, it prints out the numbers 5, 4, 3, 2, 1, just like we'd expected. Let's turn next to the algorithm COUNTUP. And here I've implemented the algorithm COUNTUP as a class called COUNTUP. Again, it takes the number to count up to as an argument from the command line, which we'll call the number. And now here's my for loop. I'll initialize the loop variable I as an integer equal to 1. Each time I want to see if I should execute the loop, I'll check to make sure that I is less than or equal to the number. And each time I've executed the loop, I'll increment I by 1. And the body of the loop is again just one statement printing out I. So let's say, for instance, that the number is 3. In that case, the first time I check to see if the loop should execute, I will be equal to 1. It will be less than or equal to 3, and so I'll execute the body of the loop, printing out the number 1. I'll then increment I, so it's 2, and on the next execution of the loop, I'll print out 2, and so forth, until eventually I gets incremented so that it's no longer less than or equal to the number. So in my example, I will finally be equal to 4, which will not be less than or equal to 3. The loop will terminate, and I'll print out done. We can use our new skill with for loops to do things like print out useful tables. For example, a table of squares. Here's my algorithm for print squares table. It takes one argument called max, which is the number of squares to be printed out. In the for loop, I initialize I to be 1. My loop condition is that I is less than or equal to max. And each time the loop body executes, I increment I by 1. At the start of my loop, as long as max is at least equal to 1, then I will be less than or equal to 1, and I'll execute the body of the loop, namely to print out the square of I is I times I. Eventually, I will be incremented so that the value of I is no longer less than or equal to max. When that happens, the loop will terminate, and we'll be done printing our squares table. I've implemented print squares table in Java, and here's my code. It will take one argument from the command line, an integer called max, and my for loop for initialization has an integer variable I equal to 1. My loop condition is that I be less than or equal to max, and each time that I execute the loop, I increment I by 1. I've put a couple statements in the loop body so that you can see using curly braces to delineate the body of a loop. I could have put all the output in one system.out.println statement, but it's clearer this way, and you can see using two statements in the body. So what's the body? Well, I'll print out the square of, and then the value of I, and then I'll complete the line with is, and then the value of I times I. As long as I is less than or equal to max, the for loop will execute the body of the loop and increment I by 1. Eventually, I will no longer be less than or equal to max, and the loop will terminate, having printed out the set of squares for 1 to max. To test the Java implementation of print squares table, I'll compile the program and then run it with the argument 8. And sure enough, it prints out the table of squares for the numbers 1 through 8. So that's a look at for as an iterative construct, both in pseudocode and implemented in Java. In the next class, I'll talk about arrays and more iteration. See you then.